Humans have been making things out of copper longer than any other metal. Archaeological digs around the world have unearthed copper vessels, tools, weapons and jewellery dating back at least 10,000 years. And in today's modern world, copper is still a mineral we really dig. Copper is used everywhere, in electrical motors and wiring, high-tech gadgetry and, of course, plumbing. The metal known chemically as Cu is essential to modern living. Pure copper is rarely found in nature. It usually occurs with other elements like iron and sulfur. To mine the copper-bearing rock, a huge drill chews into this Arizona terrain. It bores around 130 holes, all at least 15 meters deep. A truck pumps explosives into them. It's a powerful mix of ammonium nitrate and fuel oil. An electronic detonating device is lowered into each of the 130 holes. From a safe distance, an explosive expert activates the detonators, staging the explosions milliseconds apart. This sequence of explosions is designed to fracture as much of the copper-bearing rock as possible. Shovels then scoop up the blasted rock, lifting 50 to 80 tons in one bite. The rock is less than 1/2% copper. Freeing the copper from it involves different techniques, depending on whether the ore is iron oxide-based or sulfide-based. To extract the copper from oxide ore, the rock is piled into specially prepared leaching areas. The rock is irrigated with a diluted sulfuric acid solution. Over months, the solution percolates down and dissolves the copper. The copper solution drains into a pond. A pump then transfers this solution to the plant. In this channel, the copper solution binds with an organic agent and floats to the surface. An acid solution is added, which increases the concentration of the copper and makes it electrically conductive. The copper solution is then transferred to a series of tanks that contain starter sheets of pure copper called cathodes. They pass an electrical current through the tank, and the copper migrates to the cathodes. Initially, the cathodes are wafer thin, but after 10 days, they've thickened substantially, becoming around 2.5 centimeters thick. Each one weighs around 125 kilograms. The purity of the copper is now 99.99%, pure enough to be used in electrical products. Freeing copper from the sulfide rock is more difficult. It starts in a massive tumbler called a sag mill. Inside, steel grinding balls smash wet rock to pieces. Exiting the mill, the pulverized rock travels over a perforated conveyor to screen out smaller pebble-sized rocks. These smaller rocks continue on to different grinding mills. The larger rocks circle back to the sag mill for another round. Once all the rock has been sufficiently ground, the copper is coated with chemicals and mixed with water into a frothing substance. The slurry flows into flotation tanks. Air blasts create bubbles that the chemically coated copper minerals attach to. The bubbles carry the minerals to the top of the tank, and they overflow. After filtering the overflow, they have a concentrate that's now 25 to 30% copper. They transfer the concentrate by rail to a smelter plant. Here it goes into several large beds. Each one is the size of 2 basketball courts. They add silica sand, creating a layer cake of sand and copper concentrate. The silica sand is known as a flux. It will serve as a purifying agent as the concentrate is smelted. In the intense heat of the furnace, the silica sand melts to form a slag that absorbs the iron and other unwanted minerals. The slag floats and the copper sinks. Its purity is now 60%. It's then fired in a second furnace, which increases the copper concentration to 98%. With the copper now extracted from the ore, the residue is poured onto a heap. This molten slag flows down like lava from a volcano. As it cools, it becomes part of the landscape. Meanwhile, in the smelter, a crane delivers the fiery liquid copper into another furnace for further purification. Inside this furnace, the purity level increases from 98% to 99.4%. The molten copper flows out of the furnace and into rotating molds. The molds shape the copper into large rectangular slabs called anodes. The slabs will become positively charged electrodes in the electro-refining process that's still to come. That process will take the purity level up one last notch. The copper begins to cool in the molds. They're doused with water to speed up the cooling process, and the copper hardens into the anode shape. A hydraulic cylinder then forces them out of the molds. Then a carrier system retrieves them and takes them for a rinse. This gets rid of any traces of a non-stick substance applied to the molds earlier for easy release of the copper slabs. Hooks formed during the moulding make it easy to rack up the slabs for shipment to a refinery hundreds of kilometres away. At the refinery, the copper slabs shed any lingering impurities in this tank as an electrical current is applied. The current causes the copper to gravitate to thinner starter sheets. The impurities fall to the bottom. The copper deposited on the starter sheets is 99.99% pure, the purity level required by wire manufacturers. They load it into a furnace that's essentially a tall shaft. Midway down, the copper melts and flows to the bottom. From there, they transfer it to an insulated metal channel, which keeps it molten as it now travels into a vertical mould. This mould shapes it into rectangular forms known as copper cakes. Copper cakes are used for manufacturing things like copper sheeting and plumbing parts. Fresh from the mould, the copper cakes are 6 meters long. A conveyor carries them to a circular saw, which cuts them to lengths required by the customer. Stacked and labelled, this pure copper cake is now ready to ship to the manufacturer. Pure copper can also be processed into rods, a form more suitable for making electrical wiring. Molten copper moves through an opening in a mould and is cooled by water. The copper forms a continuous rectangular bar. These grooved rollers will now take it from rectangular to round and reduce the diameter substantially. As the copper travels through the grooves, it becomes an 8mm thick copper rod. The rod exits and the machine loops it into coils. They land neatly onto a steel spool. Machinery then compresses the copper coil, squeezing it down so it will take up less space when transported. There's one last squeeze from an overhead press. And the tightly coiled copper is secured with strong plastic binding. From the Earth's crust to the factory floor, it's been quite a journey. Shipped to manufacturers all over the world, it will be drawn into electrical wiring. And that's the end of this highly charged episode. And sadly, now you know how it's made,